Okay, so let us discuss about the Hough transform. But okay, let's discuss about the case studies first. So first of all, let's discuss about the human iris location. So the iris part of eye is, for example, so in your eye, this is your iris part, the ball, the eyeball. Okay, now this is your iris. Now this is very important in computer vision. For example, there are three reasons. Okay, it provides useful cue for human face analysis. Second is it can be used for determination of gaze direction. Now this is an important concept of gaze direction. For example, if you are unlocking your mobile phone by just looking at it, right? For example, you have face unlock. So what it does is it does not get unlocked if you are looking away, right? It only gets unlocked when you look at it. Okay, so the gaze says, the gaze means where your eyes is, your what is your direction of viewpoint. For example, if you are looking straight at 0 degree at your phone, it will get unlocked. And there is also some scope of variation. For example, if you are looking a slight left, slight right, it will also get unlocked. But let's suppose if you are looking at 40 degree left or 40 degree right, it won't get unlocked. Okay, so that's why gaze direction is important. And yes, it is also for example biometric purpose that we already had discussed. Now next thing, I have include in the book Computer and Machine Vision. You can check this out on page 325 and 220 up to 327. Let us discuss about the Hough transform. Now you can see that there are two images. Now in the left images it is very clear that it is a cycle. Now in the right image it is also very clear that this is a cycle, but at the same time if you look at wheels, okay, so now if you want to make a perfect circle of the wheel, now how will you identify which point to be considered? For example, there are many points in this area. Now which one is to be considered here? Now that is a problem because we have so many points. We also have this noise, so there is a good possibility that there would be some noise, right? So now at the same time, so this is a problem that we are going to find out through Hough transform. Okay, so let me repeat. For example, if we are looking at this circle, the wheel, okay, so in this image there are many small dots, but we can also see that there are many noise as well. So which one do we have to consider in order to make the perfect circle? Okay, in order to represent the perfect wheel, which one do we have to consider? So Hough transform solves that problem. So basically the fundamental or Hough transform is for line detection. Okay, so if there is a line, Hough transform is used to detect this line. Okay, now the variation of Hough transform is also used to detect circles and all other basic shapes. Okay, now again let us discuss about the Hough transform. So as we all know that line equation is y is equal to mx plus c. Okay, this we all know. Now what if we reshuffle this? So we are taking this to the left. Okay, we are taking this to the left. So now this will be mx plus y. Okay, minus mx plus y. Okay, so now this is a very interesting concept that we'll discuss very shortly. So first of all, for example, we have all these points. So we need to define that if there is a straight line. So now there are many straight lines. For example, you can say this is a straight line. You can say that this is a straight line. Now if you are not talking about straight line, this is also a line. Okay, this is also a line. This is also a line. This is also a line. Now this is also a line, right? So there are many possibilities, but what are Hough transforms, but our Hough transforms output is this. So we can clearly see that there is a line. Now, as we also already discussed, that this is the line equation. Okay, now we have manipulated this line equation to look something like this. Okay, now there are two planes. For example, now listen to me very carefully. For example, this is your image space. Okay, this is your image space. Now we have 1 2 3 4 5 6. We have 6 points that defines a line. Okay, things should be clear right here. Okay, now we have, for example, 3 points in the image plane that says that we have a line. Okay, now in the there are different visions. For example, listen this very carefully. For example, if we have this pen, okay, if we have this pen, we are looking at, the length is very, you can say, for example, it is of 10 inches maybe. Okay. Now, what if we are looking at, this is our view. Our eyes are looking it from this view. Okay, but what if we look it from this view? If we are seeing this from this view, so you will be able to see a point, right? You will be able to see a point. Are you getting it? For example, if we have a a stick here. Okay, if we have a stick here, so now we can say this is a stick because it has some kind of length. Okay, because we are looking from this vision. But what if we are looking, our point of view is this angle? If we are looking from this angle, we won't be able to say that this is a stick. This will be just a point to us. Okay, so likewise, when we see in the image space, this is a point. Okay, but when we see the parameter space, which one is parameter space? This one is your parameter space. See this one. Okay, now when you see a point in the parameter space, it will look like a line. Okay, there will be a line. So this thing should be clear to you. I have given you an example to visualize this. Okay, so this is your image space and this is your parameter space. Now any point in your image space will be having a line in the parameter space because we are looking it from the parameters point of view. Now if we consider more points, for example, all these points, if we consider all these points, we'll be able to see that there are some more lines. Okay, so but you can see there is one pattern. There are multiple points, and when we are seeing this point in parameter space, we can see that there are straight lines. Okay, but there is a pattern that says all these lines would pass from this point. Okay, all these lines should pass from this point. Now again, like this, you can see this point. Okay, so now this is the basic intuition behind the Hough transform. So what we are going to do is, try to take the overview of this. The point in the image space is a line in the parameter space. So if we have a line in parameter space, we would be having a point in the image space. Okay, so these are quite opposite of each other. Now let us discuss about this image. Okay, we have this image, we have 3 points. Now let us discuss about, again we are discussing line detection. Okay, Hough transform is for line detection. Now there are 3 points. Okay, so now we have to decide whether it creates a line or not. So what we are doing here is, what we are doing is we are creating a 2D array. Okay, this is called accumulator array. So we are initializing each value with 0. Okay, clear? So what we did as of now is we consider an image, and since there are points, we are curious to know if it forms a line. if a line detects. Okay, so now next thing is we are creating an accumulator array and all the values are initiated with 0. Okay, now what we are doing is for each edge point xi, yi, for example, you can say this is your x1, y1. This will be your x2, y2. Okay, so for each edge point, this is your edge point. Okay, now what we are going to do is accumulator plus 1. Okay, accumulator plus 1. Now in accumulator there is value 0. 0 plus 1 will be 1, definitely yes. So it is saying whenever we are getting a point, and if we are seeing a line, we'll just update the value and add it by 1. For example, for this point there will be a line in this space. Okay, so for example for this point, this is the line. Okay, now what we have done is we have incremented it with 1. As simple as that. See, this is your parameter space and this is your image space. Now thing is clear that every single point should be having a line in the parameter space. Now whenever we are plotting this in the parameter space, it is giving me these points. So now in these points I'll add a value 1, as simple as that. So when I added this value, you can see that all this diagonal values are 1. Okay, understood. Now let's consider the second point, this point. So what we have done is, again we have plotted this point in the this space. This is your parameter space. Now since we plotted this, now we can see that 1 1 2 1 1. Now things are very clear. For example, if there was 0, we added 1 to it, it became 1. Okay, now here it was 0. 0 plus 1 is 1. Now since there was 1 and we are adding 1, so it will give us 2. Okay, so likewise these two 0 will become 1 and 1. Okay, now likewise when we consider our third point, for third point, for example, this is the line. Okay, so for this line, as soon as we encountered 2, we added 1 to it, so it will become 3. So this is a very simple algorithm. Now this will be our accumulator array by the end of considering these 3 points. Now what we will do is, our last step is to find a local maxima in this space. Local maxima. See, if we are considering this array, the local maxima will give you 3, and now this 3 is greater than 0. Okay, greater than 0 and greater than 1, and it is also greater than 2. So there is definitely a line. See, line means that there are multiple points. See, line means there are multiple points that comes to same place when in the parameter space. So this point is 3. So this is what our Hough transform does. So now we know that we can detect a single line with Hough transform. Now there are different variations. For example, it can also find circles and ellipse and all. Okay, so and there are many merits and demerits. For example, works on disconnected edges. It also works on disconnected edges and relatively insensitive to occlusion and noise. For example, if there is some overlapping, for example, this is a circle, and if there is an overlapping, so it is insensitive to that occlusion, and it is also relatively, see, it says relatively insensitive. It is not completely insensitive, but relatively insensitive to noise. Now, effective for simple shapes, for example, lines, circles, and etc. Complex, for complex shapes, we consider generalized Hough transform. Okay, now, so the trade-off here is work in image space and then parameter space. So there are two spaces, image space and parameter space. So you have to switch these two spaces, and you have to work quite a lot to detect this line. Not actually you, your system has to do a lot of work. It will eat up a lot of memory, storage, processing time, resources, in short. So that's why this is a trade-off here. So there is an example you can see. For example, this is your machine and there is an occlusion. This is an occlusion. Okay. So now detected lines are these. So now you can see that this is not perfect, right? This is not perfect. And for circles, this is the output of the Hough transform. For example, these are the different coins what we can see, and Hough transform gave us output that there are 4 coins at these locations.